Welcome to the series that takes you to the heart of America and reveals the inner workings of our country as you have never seen them before. We're going to go on quite a journey. We'll travel coast to coast across this sprawling land to discover the habits, the rhythms, and the secrets you only notice when you step back and see the big picture.
I'm Yul Kwan. I've worked in law and government, business and journalism. I've even won the reality show Survivor. And in every part of my life, I've been fascinated by the same things: systems and networks.
None have shaped us more profoundly than the ones we use to manufacture, to build the things that fill our lives and fuel our economy. Whoa, wait, what? In this episode, we'll uncover a revolution, a transformation that's well underway, reshaping who we are and what we make.
We'll enter a surprising world of constant change, ruthless competition, and relentless innovation.
I love a robot.
Yeah.
Step back just a little bit.
From the simplest steel screw to the sleekest new car, from a tiny silicon chip to a behemoth aircraft carrier.
We'll explore the interlocking chains of supply and demand, part and assembly, material and manpower that make our country work. 15 seconds. Ah! Here, just finish it for me. This is a story of how America creates. This is America Revealed.
America Revealed is made possible by the Corporation for Public Broadcasting and by contributions to your PBS station from viewers like you. Thank you. Manufacturing has shaped America. From shore to shore, our identity has been defined by the things we make and the way we make them. But manufacturing is not what it used to be. And this place shows why. This is Savannah, Georgia. It's been a trading center since colonial times. And today, it's one of the fastest growing ports in the United States.
Things have changed since the days of settlers, corn, and cotton. These giant ships come here from all around the world, filled with all kinds of manufactured goods, like computers, ovens, flat-screen TVs, and even American flags.
We used to make these things ourselves. Now they can be made more cheaply abroad, so we import them packed tight inside these containers. We import so much, in fact, that these docks are loaded with more than $130 million worth of goods. And they won't be here for long. Because this port runs 24 hours a day, 7 days a week. So before you know it, every container you see here will be gone, headed off to stock America's stores.
These ships will be gone too, but what they take with them may surprise you, because when they go, they'll be filled with America's biggest export. And it's not TVs or computers or ovens.
It's something else. This is the only warehouse in the port that stores American-made goods. It's the size of 7 football fields. And right now, all it holds is paper. Rolls and rolls of paper. That's because we ship more containers of paper to the world than anything else by far. And one man is responsible for keeping it all moving.
So Larry, everything in here is going to be exported out of the country?
That's correct. Here, in this particular facility, we do nothing but export paper.
Larry Gurkis manages this warehouse. He knows where all the paper comes from, where it's going, and why.
It's going to go to Asia, parts of Europe. A bulk of this goes to China.
And what do they do with all this paper?
Well, it comes right back to us in boxes. All these different electronics that we import from China is boxed up with this paper we send over to them.
So all this paper is going to China. They take it, they make it into boxes to package all the stuff,
That's
to import
correct.
back into this country.
That's correct.
So it's just kind of going back and forth.
That's right. Well, I would say you hit it on the nail.
Looking around, this place seems like a sign of troubled times. Paper is what's called a low-value good. It's a product, unlike, say, a television, that's worth little more than the raw materials that go into it. So for many of us, this is an unsettling picture. A picture of a country that's importing more than it's making. Of a manufacturing system that's dying. But if you look beyond this port, you'll see something very different. Manufacturing is not really disappearing from America. It just doesn't look like it used to. A whole new landscape is emerging, filled with new ideas, new people, and new places. Like here, Chattanooga, Tennessee.
This site, from a logistics point of view, it's a beautiful site because it's adjacent to an interstate. You don't have any nearby residential. It's got dual rail access. It's just a terrific site.
This is Dennis Cuneo. He works as a site selector, helping companies find locations for their factories. He specializes in high-value manufacturing, in goods that are worth far more than the cost of their raw materials. And here is what he's so excited about. It's America's newest auto plant, a $1 billion state-of-the-art facility filled with all of the latest technology. But this factory wasn't built by Ford, Chrysler, or General Motors. It was built by Volkswagen. And while you may not think of Volkswagen as an American car maker, maybe you should. These cars are made in America, out of American-made parts, by newly hired American workers, and have been specially designed to be sold in American markets. And Volkswagen isn't the only foreign company being drawn to our shores. What's happening here is part of a much bigger picture. This is what America's auto industry looked like in 1980. Each dot is a factory run by a U.S. automaker. And in the last 30 years, more than half of them have closed. While companies like Honda, Toyota, BMW, and Nissan have opened new factories, spawning a vast network of American-owned auto supply firms, all these dots you see here. It's been a major boost to our economy and a profound change to our auto industry. A change that Dennis Cuneo has witnessed firsthand.
Most of the new plants built in the United States over the past 20 years have been by foreign auto manufacturers. They have put about $44 billion of new investment in the United States. They employ about 80,000 people.
I think a lot of people would be surprised by that because I think the common assumption is that all these manufacturing jobs are going overseas to places like China.
The labor-intensive, low-cost, low-wage cost jobs are going to China. But the high-value-added jobs are still staying here, and the fact that this large multinational corporation, very sophisticated, could build these cars anyplace, has chosen to put a $1 billion investment here, tells you that the United States is still a good place to build stuff, especially high-value-added stuff.
There's one obvious reason that America attracts this kind of investment. We're a huge market. We buy more than 12 million cars a year. But there's another reason that's far more significant. Our factories are in the midst of a revolution. They've embraced a new way of thinking about manufacturing. One extraordinarily focused on efficiency. And here at Volkswagen, you can see that thinking in action. Businesses have always cared about efficiency, but this place has put efficiency on steroids. To be profitable, these people need to make 500 cars a day, and each car has about 20,000 parts. So every movement is coordinated, every action plotted out. Some of this may look familiar because the basic workflow was established over a century ago. Back in the days of the Model T, when Ford auto workers first installed interchangeable parts on a moving assembly line. But don't be fooled. Here at Volkswagen, the assembly line is being utterly transformed. And at the center of it all is something that Henry Ford never dreamed of. Robots. There are robots everywhere in this factory. Welding, painting, riveting. They do more than half the work in the plant. And in many areas, they do all the work. Which is just fine with machinists like Vicki Holloway.
What's the stuff that you do versus what the robots do?
What I'm doing is just getting it ready.
Getting it ready for the robots to work on it?
Getting ready for the robots to work on it, right?
Okay.
The robots do the work. Each robot know exactly what move to make.
Okay.
And then they're finished.
Okay.
And then they're waiting on the next car. It's great. I love the robots.
Yeah.
Step back just a little bit.
All right.
Okay.
Robots do things that are dangerous and difficult, things that require tremendous precision, and they do them fast. The result? Incredible efficiency, but many fewer jobs. It's caused a radical shift in the way our country works. 20 years ago, American manufacturing looked like this. Each dot represents 1,000 factory workers. Today, a third of their jobs have disappeared. And in some places, that number is even higher. Detroit has lost almost half its manufacturing workforce. This is why many people think America doesn't make anything anymore. But that's not true. Because if you look at our country in terms of production rather than employment, you'll see something very surprising. These bars represent the value of what American workers made in 1990. And this is what they make now, nearly twice as much. Over $1.7 trillion worth of goods each year, more than China, Germany, Japan, or any other country on Earth. We've entered a new era of hyper-efficiency. Our factories are producing many more goods with fewer people. And all this has resulted in a new kind of auto worker.
You're yellow, I need a red.
To understand this new worker better, I've come to Volkswagen's training center. It's the first stop for all their new employees. And today, training starts with a game.
So I want 10 trucks, 7 minutes, push system. Ready? Go.
The man in charge is Albert Grazer, Volkswagen's master trainer, part philosopher, part drill sergeant.
We got a minute into this, I don't have a truck on the table.
He's put me on an assembly line with 5 other people and given each of us a simple job. The idea is to see how we can do it better. Putting together 10 in 7 minutes sounds easy, but it isn't. Everybody's struggling, that seems to be the whole point of the game.
All right, he's waiting on you.
This is stressful.
It's stressful.
It ain't easy.
2 minutes and 4 seconds. We got our first truck. We need 10. We need to go. You see this here, right? I've got 3 trucks, 3 trailers waiting for cabs.
Sir, yes, sir.
We've got 40 seconds left. 30 seconds left. 15 seconds.
I'm the holdup.
Come on, I need another truck.
Here, just finish it for me.
All right, time. Time. Everybody stop. All right.
In the end, Albert doesn't really care if his new employees can build toy trucks. He wants them to understand how the factory works so they can improve it.
This gentleman, as he was putting the rims in a tire, he would pick this up from here and set it on there and push that down. There's no value in that. The time that it takes him to pick this up and put it back and forth is unnecessary in that. What I want him to ask me for is to recognize if this was permanently mounted there, he could completely eliminate them steps, saving a lot of time.
And that's a little bit counterintuitive for me because I always thought the whole industry was moving towards automation and that the role of the individual is slowly diminishing. But what you're trying to do is sort of the opposite. You're trying to empower these employees.
Yes, because robots can't think for themselves. Somebody still has to program the robot. Somebody has to tell the robot what it needs to do. And the only way we're going to know that is to get people to recognize where there's waste.
The lessons Albert is teaching his workers echo well beyond these walls. They're part of a new philosophy that's impacting every industry in America, including one of our most dominant. The arms industry. America makes more weaponry than every other nation on Earth, by far. From missiles to submarines, fighter jets to spy balloons, we spend over $400 billion a year just making arms. That's 6 times more than any other country. But historically, this enormous industry has been plagued by inefficiency. From 2008 to 2010, the U.S. defense budget had $135 billion of cost overruns. And with a ballooning national debt, arms makers are under pressure like never before. This is the USS Gerald Ford, a nuclear-powered aircraft carrier lying in a dry dock in Newport News, Virginia. Even though it's budgeted to cost $10 billion and will be the most advanced aircraft carrier on the planet, looking around, this shipyard looks like something from a bygone era. But looks can be deceiving. Beneath all the rust and grime, this place is starting to change, dramatically.
So this is our main machine shop. What you're looking at here, these are the propeller shafts that connect the main engine to the props at the end of the ship.
How long has this building been here? It looks like it's been around for a while.
Yeah, this building's over 100 years old. Part of the fascination of this business is the kind of the dichotomy of the old and the new. You have these old buildings, some old facilities, and you're doing some of the finest machining in the world.
Engineer Tim Schweitzer is working to change the shipyard by using the same approach as Volkswagen, a philosophy called lean manufacturing.
It's a term that came out of the car industry, but to us, it's all about trying to identify and cut out as much waste as you can to lower your costs and improve the efficiency and the speed by which you do your work.
So basically, you're trying to get rid of all the fat in the whole process.
That's exactly right.
So what are the things that you're doing now that were different from before?
We used to do what we call stick-built carriers, and you build every piece into the dry dock and build a carrier from the bottom up. Now you see we do a lot more modular construction.
What Tim's doing is to use the lean philosophy to reinvent the way warships are made. In the past, they were built like this. The hull was constructed first in one big frame, and everything else was built into the hull as it went up. The work was slow, complicated, and cramped. This is how ships are built today, in hundreds of separate pieces spread out across the yard. The site is now so sprawling that foremen like Lawrence Darden have to ride bicycles across it. because it takes too long to walk.
So Lawrence, what do you and your crew do here?
What I do is similar to putting a house together. You know, you got your home, you got different rooms, and I put all the pieces together until we complete the whole ship. It's very cost efficient, and it saves a lot of time.
To keep Lawrence and his crews as lean as possible, the engineers here have developed their own computer software, a kind of virtual reality blueprint system that allows designers like Brian Anderson to plan the installation of each piece of the carrier. Commercial shipbuilders have been using this type of software for years, but in this tradition-bound industry, it's revolutionary.
The predecessor of the Gerald Ford was done in pen and ink. So they would draw ink and vellum, and they would draw the drawings. The problem with the ink and vellum was the guy designing the piping system would pretty much design in a vacuum. He wouldn't know what everybody else was doing. And that's exactly what the 3D product model gives you, is you get all of the systems in the space at one time, and you start to see where the systems interact and where there are fouls.
Okay.
So this piping system designer, he'll be able to see, do I clear this fire main system?
And this prevents you from finding mistakes too late downstream.
Correct. The main thing of it is when we find them here, it's much more efficient to correct them while they're still digital data before we're actually cutting the steel.
It's too soon to tell if the carrier will come in under budget. But the lean philosophy has already saved the shipyard hundreds of millions of dollars, showing that even America's most traditional industries are embracing efficiency. But sometimes, improving efficiency alone is not enough.